All right, today we are looking at data wrangling with DeepLire. Okay, so DeepLire is another package in the tidyverse, and it's probably my favorite thing to use. Okay, it's kind of like tapply. Okay, so you guys learned tapply, right? In Stats 20. And so there's a lot of similarities with tapply, but in my opinion, and this is just my opinion, I feel like DeepLire makes things easier. So anyway, we'll this is what we will cover today. Okay, so DeepLire's core part of the tidyverse, you'll just call library DeepLire if you just want that one, or if you're doing stuff in the tidyverse, just call library tidyverse. And it will load kind of, I think, all 8 or 9 packages in the tidyverse, and you'll be good to go. Okay? These are your primary, this is what DeepLire offers, okay? These 5 verbs. And, I mean, there's other things you can do with DeepLire, but I would say these are the 5 ones. These are the 5 primary verbs that DeepLire offers that makes data wrangling, data manipulation really great, right? So, and I guess the idea is that by the time you get to DeepLire, your data is already in tidy form, okay? So we covered on Friday how to get data into tidy form, meaning each column is its own variable, all right? And so if you got each column in its own variable, then you're well suited to use DeepLire, okay? And so DeepLire has select, which allows you to pick the variables that you want, has filter, okay, to pick the rows or the cases. Mutate will add new variables. Arrange will kind of sort the results, and summarize reduces the rows down, okay? And these all kind of combine with this other like super function called group by, and we'll take a look at that. All right. Here's a cheat sheet from RStudio itself, okay? And it's useful to have. It's useful to print out somewhere and refer to it, okay? And so I think we'll talk. We'll do most of these things, okay? So really, I'm only covering like the basics of each of these things. So there's like filter, but then there's all of these other things, right? And then there's arrange, and then there's a bunch of other stuff, and then there's select and pull and stuff. But I'm just covering the primary ones, which are filter, arrange. Let's really just filter and select. There's arrange, mutate, and then we'll look at summarize along with the group bys. Okay, but this is what you got here. Okay, so all of these examples I'm going to be using this data set called the Star Wars data set. I don't know if we got Star Wars fans in here. I don't know. Anybody? Okay. Okay. All right. I see you. All right. Great. Okay. So I was, I was a big Star Wars fan, but so anyway, what this is it's got a bunch of people from the Star Wars universe, okay, and it's from the first 7 Star Wars movies, okay, but really most of it's coming from kind of the first 6, because a lot of the details for characters in the 7th movie have not been revealed, but it's got Luke Skywalker has a height in centimeters and mass in kilograms and things like that, and where their home world and stuff. And then again, because it's a tibble, or we're in the tidyverse and everything comes back as tibbles instead of data frames, it comes with all of this kind of information here. And so we'll apply a DeepLire to this. Okay. All right. So the first function is select. Okay. And so the way we select things is you'd say select, and then you give it the data frame, and then you give it the name of the columns you want. Okay. So here it says I want the name, the home world, species, and films. Okay. And interestingly enough, films is stored as a list because Luke Skywalker's in 5 films, whereas C-3PO is in, R2-D2's in all 7, and I guess C-3PO is only in 6. I don't know which one they excluded him from, but maybe that's not accurate. But okay, what's that?
I'm trying to figure out
which one he's not in, right? Okay, well, I'm not sure. I'll have to look at this, right? Okay, and then we got Darth Vader and stuff like that. Okay, and so this is the information that we've got. Okay, this is like, so when you look up help on select. Okay, so if you could come over here to the console and you type in give me help on select. Okay, it will kind of give it to you like this, and basically. From here on out, I'm going to use the pipe, all right? I'm not sure how familiar you guys are with the pipe, but the idea with the pipe is that, on the previous slide, I had select Star Wars and then name, home world, species, film, and then the pipe basically takes the thing that comes before the pipe, and in the tidyverse, generally we're working with tibbles, okay? So you take the thing that comes before the pipe, which is a tibble or a data frame, and then when you pipe it into select, it goes into the first argument, okay? So this thing, Star Wars piped into select, is exactly equal to saying select Star Wars, comma, and then all the other arguments, okay? So whatever that, when you use the pipe, it's gonna take whatever comes before the pipe, and that's this percent greater than percent thing, okay? Kind of looking like an arrow, and it puts it into the first argument of the function that follows. Right? Does that kind of make sense? What's going on here? Okay, and so these two things give us exactly the same result. Okay, now percent greater than percent is a tiny bit annoying to type. All right, and so the shortcut to insert the pipe, at least in RStudio, and after you've loaded, after you've loaded the tidyverse, is Control Shift and M, okay, and that will just keep inserting pipes, okay, which is very convenient, all right, especially when you're typing. All right, and so so this example was I just gave the names, okay, and notice when I call the names, you can put quotes around it. You don't have to put quotes, okay. You can also put in the index position, like I want the 3rd column or the 5th column or whatever, okay? Other things is you can say, I don't want these columns, okay? I don't want name, eye color, and birth year, all right? And it's gonna get, there's 13 variables in the original data set, and so, it pulls all the other ones, okay? And here I put them into head 1, just so we get the first row, otherwise it's gonna give us however many rows we have, 87 rows, okay? So we say, we don't want these columns, that's fine, with the negative sign, okay? And then again, you can use colon notation. So you can say, I want the columns name through eye color, all right? And as they are arranged in the original data set, it's gonna pull the columns. So here's the original data set. It's gonna pull the columns name through eye color, okay? Using colon notation, which is convenient. Okay. When you load in DeepLire or the tidyverse, we also get a whole lot of special selection functions. Okay, and you can learn all about these with select_helpers. Okay, you ask for help on tidy select the select helpers, and so some of these are contains, and you give it a certain character string, starts with a character string, like the name of the column starts with something, or the name of the column ends with something, the name of the column matches a regular expression, or you can say I want all the columns, or you can give it a numeric range. And so this is useful if you have, sometimes you'll get columns that are named like x1, x2, x3, or v1, v2, v3. And if you look up the help on numeric range, it'll give you the specifications. You give it the prefix and basically the number range, and it's gonna kind of paste those together to get a thing. Okay. Or and another thing is you might have in somewhere else you might have a vector where you are storing the column names that you want to select. And so if you have an object already created, which I've called name vector, okay, you can put that into one of, and it's going to select the columns where the names are stored in this vector, which can be convenient if you're building some kind of function or loop dealing with unknown columns and stuff. Okay, so here's just a few examples. So here I'm doing Star Wars. I pipe that into select, and I'm saying select columns that end with color. So it ends with color, and it pulls hair color, skin color, eye color. And this is the first one, head one, and this is Luke Skywalker with blonde hair, fair skin, and blue eyes. Okay. We'll cover regular expressions Wednesday, and so you can select column names using regular expressions. And so here we're going to say select matches, and then I give it a regular expression. $$ basically means that the column name ends with an S. The $ means basically ends with the end of the line thing. Okay, and so this pulls columns mass, species, films, vehicles, starships, which all end with S. Right. So these are nice. These are available only with DeepLire. Okay, you can't do stuff like ends with color is not an option for anything in base R or something like that. Okay, so it's really nice, right? So these are great. We also have filter rows. Okay, so there's a function filter, and this will select only the rows that meet a certain criteria. Okay, so any criteria that can be expressed as a logical vector. Okay, logical vector with basically name equals R2D2 equals R2D2 is going to be a logical vector which is basically false for everything and true only where name is equal to R2D2. And basically filter can use anything where you've got a logical vector. Okay, so you got a logical vector somewhere, and it can use this. Right. So in this case, it just pulls the one character R2D2, and I guess this is how tall and how heavy R2D2 is. No hair color. Okay. And then the birth year is, I guess, in the Star Wars universe, it is measured as in before the Battle of Yavin, which I guess takes place, at the end of the first Star Wars: A New Hope, the destruction of the. Anyway, all right. First Death Star, and that was again time. Time is a numeric variable, but we have an arbitrary 0 point, right? And so this is negative. So I guess R2D2 is 33 years old. And I don't know how they measure years in the Star Wars universe, right? There's not like there's revolving around the same sun. So I don't know what this looks like, but okay. Anyway, all right. Here's another example of filter. Okay, so here, if you can specify multiple conditions, all right, and if you use the comma, it's equivalent to using the and sign, all right? So whatever's more comfortable, you can use the and sign, you can use the comma, and basically, this is height less than 175 is a true false vector, and then species, and then %in% is another operator that basically just is useful for just checking to see if a string is, one of certain strings, right? So the percent in percent is a very useful operator. I think you guys know most of your other logical operators, right? The equals equals, not equals, right? I mean, exclamation equals, greater than, less than, I don't know. And then you've got your and your or, okay? So the human and droids that are shorter than 175, so I guess Luke and Leia, I don't know. Okay, there you go. Is something surprising here? Like C-3PO is 112? This seems crazy to me, but I don't know. All right, this comes from some Star Wars website. Okay, filter can be paired with regular expressions. All right, and again, we'll cover regular expressions on Wednesday, but string detect is the regular expression for detecting certain matches. Okay, and so you can say, does this match, right? So caret, or whatever you call this symbol, I call it the caret F, just means the text has to start with a capital F here. Okay, and so here this is, select the rows where the name begins with the letter F, okay? And we apply filter to this, okay? So filter string detect this, and then we get, I don't know who this is. Vinny something? All right, who is that? Who said they're a Star Wars fan? Let's see. Filter string detect. I just want to see who this is. Okay, what? Did I do something wrong? Oh, silly. I have to specify the thing. Finis val something. Okay. Well, we'll just select the name. Finis valorum. Do we know who that is? Let's find out who this is. Okay, so the films are stored in a list. So I'm going to extract them using the double selection, and we want the first thing. And the Phantom Menace. Okay, that's why. I don't know. I don't remember any of the characters from the Phantom Menace. So when I rewatch the saga, that's the one I skip. I go 4, 5, 2, 3, 6. Okay. All right. Okay. And then if you want to use or, you use the vertical bar. That's regular old procedures. And then you can pipe the results into each other, right? So filter selects all the columns, okay? And then you might say, well, I only want certain one of these columns, right? So here we're going to say, let's get everybody who has no hair, or no hair color is none, and then eye color is black, and then let's figure out the name, species, home world, and then let's just look at hair color and eye color. Okay, so we get Darth Vader and Greedo and IG-88 and so on and so forth here. Okay, and there you go. So either have no hair or has black eyes. Okay, so that's filter and select. All right, and you can do quite a bit with just those two to pick your rows. All right. You want to create new variables, use Mutate. Okay. New variables are in the when you create a new variable, they're going to be in the last column. Okay. So you often use this with select. All right. So the way this works is you take kind of your data set, and then you call mutate. Okay. And then here you specify the name of the new variable you want. Okay, so the new variable I want is going to be height inches. Okay, so for us Americans who are used to the non-metric system, we have to take the number of centimeters and divide by 2.54, right? So we do height divided by 2.54, and then we say we want to store this in this variable called height inches, okay? And then if we just do this for the first row, okay, it doesn't look like anything has happened, but now we see there's one more variable, okay? So everything used to be 1 by 13. Now we have a 14th variable, and then the last variable listed is height in inches, okay? Height in. And so here, before I just call head, I can just say, select these 3 columns. Select the name, the height, and the height in inches, okay? So we see Luke Skywalker with a height of 172 centimeters or 67.7 inches is what his listed height is here, okay? So one thing to note about Mutate is that because it's going to add an entire column, the column that you're creating has to have the exact same number of values as there are rows, right? So every row needs to have an entry in this new column that you're creating. So you've got to, so things like, if you called mean, it's not going to work, okay? Because what does mean do? Mean takes a whole bunch of numbers and it produces one value, okay? So that's not going to work. But the cumulative mean will, okay? So the cumulative mean basically takes the first value and it says, what's the average of all the values I've seen? So here we have 77 and the cumulative mean is 77. The next value is 75 and the mean of 77 and 75 is 76. And then the next value we have is 32. And so we get 77, 76. The mean of these 3 values is now 61.3, okay? And so it dips down. Darth Vader is tall, 136. Or not tall, has a mass of 136. And so that brings up the cumulative mean up to 80, okay? So Mutate is great, but you just have to keep in mind that every row you're going to be able to create some kind of value, even if it's a missing value, but there needs to be something for everything. So the vector of values that you are creating has to have the same length, okay? And so that's Mutate. So as far as Mutate goes, there are some useful functions here, okay? There's pmin, which is element-wise min and max. And then, so there's pmin and pmax. And then there's cumulative min and cumulative max, along with cumulative sum and cumulative product, okay? And similarly, there's also cumulative mean, right? There's also between, which is just going to give you kind of true-false values. And then there's lead and lag, which copies values with some kind of offset. And then there's entile, which will bin vectors into values into kind of n buckets. So if you do entile 2, it's going to split it into basically the values below the median and values above the median. And then if you do entile 4, it'll basically label your smallest values in first quartile will be 1, and then the largest values in the fourth quartile, or between Q3 and Q4, will be labeled 4, right? And so if you do entile 100, you're basically calculating percentiles, but you could put in any value here, and you'll get it'll split up your data into that many bins. Okay, so here's just an assortment of some of these mutate functions that you can use, right? So here, all I'm doing is I'm just selecting the name, the mass, and the birth year. Okay, so if you think, what are we looking at? So if we do Star Wars, select name, mass, birth year, we're starting off with just these 3 columns. And then when I do, so we start off with these 3 columns, and when I do mutate, I'm creating 4 additional columns. The 4 additional columns are cumulative mass, the ratio, mass year min, and lag 2, okay? And these are just arbitrary things. None of these things make any actual semantic sense, okay? I mean, cumulative min of the mass, sure, that makes sense, okay? And that's basically what is the smallest mass that we have seen so far, right? So at 77, 77 is the smallest thing we've seen so far. At 75, then we see 75, so that's the minimum value, cumulative min. And at 32, 32 is the cumulative min, okay? And as we see other values, the cumulative min remains at 32, okay? And so mass, here I'm doing mass divided by the mean of mass, where NA.rm is true, okay? And so this is the ratio between this character's weight, okay, or character's mass, versus the average mass of all the characters in this data set, okay? So mean of mass is practically just one value, right? So this is one value, and we're just basically dividing all the mass numbers by a single constant, and that's how we're getting this. So this is fine, okay? The p-min is different from the cumulative min. It does element-wise minimums, all right? And so here we would provide it basically like two arguments, like mass and birth year, and it's going to go element-wise and say which value is smaller, okay? So between 77 and 19, which one's smaller? 19, right? So this doesn't quite make sense. Are you younger than your mass is basically what the question is asking, or which is smaller, your age or your mass, and give me that value back. So Luke Skywalker was 19 at the Battle of Yavin, which is less than his mass of 77, so we put down 19 here, okay? Whereas R2-D2 was 33, and his mass was 32, so we're going to put down 32 here, okay? So that's what we get, all right? So we're doing the min between these two columns, and that's p-min, all right? So it's element-wise minimum calculations. So within a row, kind of like what's the minimum of these values you're giving. Okay, and then lag2, or lag, is just take one of these columns, okay? So in this case, we're going to do mass year min, okay? And then you provide it some kind of offset, okay? So you can do mass year min, lag2, and then everything's going to be offset by 2. This can be useful if your data is like time data, time series data. You might want to be able to compare, this month versus the same month last year, right? So you might have monthly data, and you want to compare this versus the same month last year, and so you might do an offset 12, okay? And then you can mutate and do kind of, so you'll have this month, and then you'll say offset 12, lag 12, okay? And then you'll have like last year's month, and then you can do a difference between this year and last year using mutate, okay? And one thing you might notice is that variables that you've just created, mass year underscore min, can be used in the definition of another variable here, okay? So here I'm defining something called lag2, and I'm using this variable that I've just created here. This is not possible in base R. So in base R, you can always create new variables, right? You just create some vector and you store it into $, new variable name in the data frame. But if you wanted to do multiple, you have to do separate operations, okay? And so so mutate allows you to kind of do it in one step. Right? So these are useful things, perhaps not so useful for this particular data set, but all of these functions are tremendously useful. And so when you learn a foreign language, there's two main parts to it, right? Or there's several main parts, right? One is you have to learn the grammar, okay? You have to learn like where do you put your verbs and where do you put your subjects and things like that, okay? And then the other part is the vocabulary, all right? And the vocabulary works well, like that's the hard part, okay? You've got to, it takes, and so this is just part of your vocabulary, right? Otherwise, you're going to be, if you don't know like if you're learning a foreign language and you don't know the word washing machine, right? You got to say like, you have to describe it as box where you put dirty clothes in or something, right? And if you don't learn these things, right? People are always like, do we have to learn all this vocabulary? And like, are you going to be tested on this? I don't know, okay? But you want to be fluent, right? You don't want to have to go wrap around and try to, like, you have to say, like, you know, how do I use this box where you put the dirty clothes in? And then you say, you mean washing machine? Oh, it's so much easier to say it that way. And similarly, you know, all of these things. Yeah, question?
When you said that the variables that you just created could then be used in the next expression,
Mm-hmm.
is that only possible with Mutate, or is that possible with any
Well, okay. So within Mutate, like, so basic, sorry, I'm not sure if I fully understand, but yeah, in Mutate, you can use, like, we've defined mass-year min here, and I'm using it immediately, almost like in the same line here, okay? And that's allowed, okay? And then if I pipe this into, like, select again, yes, of course, I can use these new variables that I've just created. Because basically, this is almost like hitting enter when I use this pipe symbol. It's like hitting enter, and I've created something, but I'm gonna do something with it right away, okay? So rather than having to save it as an object and then use that object in a new thing, I can just kind of use the pipe and use it right away. And so yes, I can use it right away, and I can use any of these new variables that I've just defined. Yeah?
Could you, like there you define ratio,
Uh-huh.
could you use it, like, let's say you need a ratio for the definition of mass year, maybe?
Yeah.
Could you put it in ratio?
Yeah, I could put, so you do, when you define these, you do have to go in order though. Like, you can only use things that have been defined at least 1 comma earlier, okay? So I cannot, like here, I cannot create a variable that uses ratio until I've at least defined what ratio is, okay? But then now that I've defined ratio, I can use ratio inside the definition of mass year min. I could use, and now that I have mass year min defined, I can use that in the future thing. And so I tried to demonstrate that here, where I'm using lag, or using mass year min inside this new variable lag2. Is that okay? Again, everything, I guess I could expand on all of these things and add more text on all of these slides, but you know, all I can say is just try playing around with this stuff and seeing what you get, okay? We have arrange. Arrange is just to kind of sort your results, okay? So it's like sort, but for a data frame, okay, or a tibble. And so here, I haven't done any kind of modifications, but if I wanted to, I could. But here I'm just selecting the name, birth year, height, and mass, and then we're gonna arrange them in descending order by birth year, okay? And then if there's a tie, we'll arrange by mass ascending, okay? So Yoda was 896 years old at the Battle of Yavin, although we didn't see him until, I guess, 4 years later in Empire Strikes Back, when he declares that he's 900 years old, okay? And I guess that's how we figured he was 896, whatever, okay. There's Jabba and Chewbacca and all of this stuff. And then I guess there's a tie between Ki Adi Mundi and Qui-Gon Jinn. And then so to break the tie, we use mass, and it goes in ascending order, okay? And that's it. And then you can arrange by words as well, okay? So if you have character strings, you can arrange it that way, and it'll do it in alphabetical order. Well, technically, it uses the alphabet of your current locale, which in most places will be English following the alphabet, but, you know, different languages, you know, the dictionary is in a different order, right? So that's what we have. Okay, is that good? Arrange. Then you can summarize. There's a function summarize with an S. Hadley's from New Zealand, and that's why he uses the S. But later he added summarize with a Z, which does the exact same thing as summarize with an S. But I learned it with an S, and so I continue to use it with an S. Okay, but everything should also work with a Z. All right, and so basically, a summary function is something like the mean, the variance, the standard deviation, anything that takes a bunch of values and returns 1, right? Because the whole point is our brains are really bad about thinking about a whole bunch of numbers all at once, and so you can just compare single values, and it's a lot easier, right? It's the whole point of having a GPA, right? It's a lot more complex to find out exactly, someone took like 20 classes and these are all their different grades and you have to think about all 20 classes. It's much easier to just say, well, what's the average grade you got? And you get a single number. And you can just say, oh, 3.55, 3.67. That's it. We can just compare these two numbers right away, right? It's very reductive, but it's easy, okay? And that's the point of summary functions. Okay, so here, much like mutate, okay, all you do is you say I want to call a new thing, all right? The summary value is going to be called average height. And then you give it the formula for how to calculate that. In this case, we're going to take the mean of the variable height and ignore the missing values. Variance of height, we're going to take the variance of the column height, ignore the missing values. Average mass is going to be the mean of the mass column, ignore the missing values. Things like that, okay? What you write over here doesn't matter. This is just arbitrary. Usually you give it names that are useful, but somebody else wants to write m_height, completely valid, okay? v_height, whatever, whatever you want to call it, right? And so functions like min and max are also summary functions. They take a whole bunch of values and they just return one, and that's going to be the min, okay? And again, you specify how this is going to be calculated, okay? And here I've got count, and this one you don't actually need to specify any variable to put inside. It's just going to give you how many things you have. And so here we have the average height of all 87 characters in the Star Wars universe is 174, and the variance is 1209 with the mass, I don't know, whatever, okay. Maximum mass is 1358. Who's that? Heaviest character in the Star Wars universe?
Java.
Jabba? Probably, right? Select name and mass. We'll say filter name. Oh, I don't know what. I don't know Jabba's full name. Okay. Starts with J, mass. Jabba Desilid, whatever. Okay, that's his full name. All right. Apparently this means the Hutt. Okay. I don't know. Is Hutt is like a race?
Yeah.
And okay, Hutties. It's kind of a rude thing to call him, right? Jabba the Hutt. Like, can you imagine, like, you, the whatever race you are, somebody calling you that? All right. I guess in Star Wars, well, they have. All right. Create groups by using group by. All right. Okay. So here I select name, height, mass, species, and then I do group by species, okay? And it doesn't look like anything has happened. This just looks like I've selected the things. But it does add this very key line that says group, and there says species, and we have 38 species groups, okay? And we got humans and droids and Hutties and, I don't know, Gungans and stuff, okay? And so group by is made powerful when you combine it with summarize. Okay, so in this case, I've taken these things, name, height, mass, species, and then we're going to group by species, and for each species, we're going to calculate these summary stats. So we're going to say, what's the mean height, what's the standard deviation of the height, what's the mean mass, standard deviation of the mass, and what's the count, okay? And then we get all of these things, okay? The Alina species, and the Basilisk species, and the I don't know how to pronounce any of these things, and we get kind of the mean heights and the things, and probably, and we get a count of 1. So some of these things, you know, we don't get, right? So, you know, there's the standard deviation is undefined when you have only one observation, right? So there's so that's where we get a bunch of not in numbers when we have only one thing, okay? And so we have 5 droids, okay, and this is their kind of mean, standard deviation, so on and so forth. So so again, you can combine any of these things, combine these different verbs together. So here, all I'm going to do is I'm going to take this exact same thing, but now with this resulting table, right? So this resulting tibble has only 38 rows, right? So the original data frame has 87 when we select him, but then after we've grouped them by species, because there's 38 different species, the result only has 38. So we're going to say, take these rows and filter them where the count is greater than 1, okay? And then let's arrange them by descending order count, okay? So that the most populous species is up top, okay? So here, all I've done is I've kind of combined this. And when you write using DeepLire, there's no like, there's guidelines on how the style should be, okay? And then so one guideline is take your data set, and then for each of the verbs, each verb kind of gets its own row. And then this is kind of one thing that I've been following is that when you're going to add columns, each new column also gets its own kind of line, right? And I'm hoping that, you know, writing it this way makes it a little bit easier to follow what we're doing, right? And so after we've done the summary, we're going to filter so to get at least rows where count is greater than 1, and we're going to take the arrange them in descending order. So there's 35 humans, and the mean height is 177. Standard deviation is this, and so on and so forth. Okay. There are some where the species is unknown, and you know this is their mean and stuff like that. Okay. And so we've got group by and summarize there. Okay. And then oh, I messed this up here. Well, I guess it fits, but you can also do group by with, say, mutate. Okay. So here I've said let's just select the human and droid species, okay, or characters where the species is missing, okay, and then so we're going to filter those rows, select just these 3 columns, name, species, and height. We're going to group by species, and then I'm calculating z-scores. And the way we calculate z-scores is we take, you know, the height minus the mean divided by the standard deviation, right? Except what because I've run it after doing group by, it's going to calculate the z-score for Luke Skywalker as a human versus other humans, right? So it's so we're going to subtract off the mean human height divided by the standard deviation of human height, okay? And as far as the droids go, we're going to subtract off the mean droid height divided by the standard deviation of droid heights, okay? And so we can see for this reason, Luke Skywalker, whose height is 172, gets a negative z-score because his height is below average for humans, and C-3PO, who's 167, gets a z-score of 0.51 because his height is above average compared to droids, right? So group by applies this grouping thing. So when you call for values like minus the mean and standard deviation, it's going to do it for its group, right? If I take the exact same thing and I just comment out the line group by, okay, then it does it for everybody, okay? In that Luke is now above average in height and C-3PO is below average in height, okay? Because it's compared to kind of everybody that's been selected and not compared to their group variable. Does that make sense? Okay. You can apply group bys on multiple data. All right, so this is a different data set. All right, we're looking at just some fake data for like cases of some disease. Okay, and we've got Afghanistan, Brazil, and China for the year 1999. Females and males, 2,000 females and males. Brazil, 99 females and stuff like that. 1999 male, 2000 year 2000 female, year 2000 male. And we've got all of these things, okay? you can group by multiple things. So I'm going to group by country and then year, okay? And then when we do that, and we're going to do the sum of the cases, it creates a group for Afghanistan 1999, Afghanistan 2000, and this is the total number of cases. So it has collapsed basically the females and the males together in here, okay? And then, so I've called this table summary 1. If I apply summarize again, so I'm taking summarize this table, it says there's 3 groups, right? So here we've got, we're going to have 12 groups, okay? Or I'm sorry, 6 groups. But now, now that we've summarized this, we have 3 groups. And if I apply summarize there, it combines the years 1999 and 2000. We get total number of cases for Afghanistan, Brazil, and China, 4, 8, and 12. And then if I apply summarize again, there's no groups here, and so it just gives us a total of 24 here, okay? This is the same thing, except this time I've grouped by year and then country, okay? And you can see it's grouped by year and then country, okay? So we have, again, the same information it looks kind of like, but it's arranged differently. But here the result is we have 2 groups by year. We have a group for 1999 and 2000. And so if I apply summarize again here, it combines all the countries and gives me a summary for 1999 and a summary for the year 2000. And then if I apply summarize there, again, it looks the same with 24 total. All right, we'll end there. DeepLire is really, really powerful, and I hope you guys make good use of the package there.